In this video, I'll talk about the dynamics of wind turbine. So we have a wind turbine here, which is rotating, and for maintenance, it is turned off, and then it takes 2 minutes to come to a full stop. The angular speed varies as a time which is given by this equation or this equation. It's exactly the same thing. So the angular speed is some time dependence which is given by this equation, and it's not linear, it's not decreasing linearly. Now we need to find out the angular velocity, angular acceleration, average angular acceleration, and the instantaneous angular acceleration. First thing, we have to find out the direction of the angular velocity and the angular acceleration. How do you find out the direction? In order to find out the direction, we have to use the right hand rule. What does the right hand rule tell you? The right hand rule tells you you need to curl your finger in the direction of the rotation, and your thumb gives you the direction of the angular speed. So if you imagine yourself turning your fingers in the direction of rotation, then you can clearly see your thumb points in this direction, this direction, or perpendicular to this way. It's hard to sometimes see. You just have to penetrate and go into this direction. Okay, so that gives you the direction of the angular speed. And now, what is the direction of angular acceleration? The angular acceleration is opposite to the angular speed. You may think, how come? Why is that? The angular acceleration is opposite to the angular speed. And it is opposite because the angular speed is decreasing. It is slowing down. It is coming to a stop. And that's why the angular acceleration is opposite to the angular speed. Let me give you a little bit more intuition on to this one. Let's say you have a ball. If you throw a ball up in the air, that is the velocity direction, but the force is acting downward, and this force also has an acceleration, which is acceleration due to gravity, is slowing the speed. So whenever you throw a particle upward, the velocity is in upward direction and the acceleration is in the downward direction. And this acceleration, which is the force making the speed of this object slow down. Okay, or in other words, when the velocity and the acceleration are in opposite direction, that means it is coming to a stop or it is slowing down. Okay, so now we talked about the direction. Now let's calculate the average angular acceleration. Before we do this, let me ask you a question. What does the term average means? Whenever you have to calculate average acceleration, average velocity, whatever, what is asking you, do you know the final position or final acceleration and the final speed and the initial speed? So all is asking about the final information and the initial information. And in order to calculate average angular acceleration, you need to know the final angular speed and the initial angular speed. We know the final angular speed because the turbine has come to a full stop. So its final angular speed is 0. Or we can also plug in the time and see it is 0. So this is the angular speed expression, and it has come to a stop in time equals to 120 seconds. That's what is given here. It takes 2 minutes for turbine to come to full stop. So if I place the 2 minutes, which corresponds to 120 seconds, into this equation, 2 times 120, that's the 0 radian per second. So which makes sense because the turbine has finally come to a stop. And the initial angular speed, how do you calculate the initial angular speed? You just have to plug time equals to 0 into this equation, and what we get is 1.44. So now we know the initial angular speed, the final angular speed. The formula for calculating the average angular speed is this. And this bar here, the little tiny line, means that's the average. And alpha stands for the average angular acceleration. And the delta here is the change in the angular speed divided by the change in time, or the time interval. The change means the final angular speed minus initial angular speed. That's the final time minus initial time. The final angular speed is 0, and we just calculated the initial angular speed, which is 1.44. The total time it takes to come to a stop is 120 seconds, and now the initial time is 0. If you solve it, what you get, the negative 0.012. Again, what does the negative sign mean? The negative sign means the angular speed is decreasing. That means the turbine is coming to a stop, or its angular speed is decreasing over the time. Now let's calculate the instantaneous angular acceleration. And you do not get confused with the average and instantaneous. Let me give you a little bit idea about what is the average and instantaneous angular acceleration means. Okay, it will be a quick thing to recall you. Let's say two persons driving cars. This is you and this is your friend, and you started from Odessa, and both you have decided to go to the Dallas. Okay, both Odessa to Dallas, both took exactly the same time, 5 hours. This is the 5 hours. The time is exactly the same. So the average speed, let's say, I'm just giving a little bit average and the instantaneous. The average speed for both of you is exactly the same, because both of you have traveled exactly the same displacement and the same time. So the average is exactly the same. But now, what you have decided, sometimes to move faster, let's say 80 miles per hour, and the other time you take a lunch break, but your person is just moving with the exactly uniform speed, but both takes exactly the same time. What that means, the instantaneous speed is way different. Sometimes for you it is just bumping up, it is going up and down, but your friend, it is a constant. So that's what the average and the instantaneous means. The instantaneous means at that particular time. For example, in your car, the speedometer tells you the instantaneous speed at that particular time. Okay, so there is a subtle difference here. So in order to calculate the average speed, you need to know the final information and the initial information, and in order to calculate the instantaneous, you need to know at that particular time. So how do you calculate the instantaneous angular acceleration? So we given is the angular speed, which is a function of time, and the instantaneous angular acceleration means the rate of change of the angular speed, or in other words, you need to take the time derivative of this angular velocity with respect to the time. Okay, so let's do this one. So this is the first derivative, d over dt, and omega t is given by 2t minus 240 over 200 squared. But now you need to take the time derivative, and I have given example here. So you have d 4x minus 5 squared over times dx. So first thing you have to take is 2 times 4 minus x, and then take the derivative of 4x, which will be simply 4. 4 times 2, it will be 8 times 4 minus x. So the same thing here. So 2, and then now you have 2t minus 240, and then you need to take this time derivative of this function, 2t, which will be simply 2 here. So practice this one if you are not familiar with the derivative and you'll get it. So 2 divided by, and this is a constant, so I'm just taking this one out. Okay, so just take it out, and this is a squared function, 1 over 200 squared. Now we have a 2 here, so 2 over 200 squared, and then 2t minus 240. So we now got the instantaneous angular acceleration as a function of time. And you see this one is a linear function, while the angular speed is a quadratic function. Now what I'm going to do is just plugging the different time. It is asking at 30 seconds. So what are you going to do? Plug time equals to 30 seconds into this equation. 2 over 200 squared, 2 times 30 minus 240, you get negative. And the time equals to 120 seconds, it is 0. Which makes sense because it has come to a full stop at 120 seconds or in 2 minutes. So this is how you calculate the instantaneous angular acceleration, average angular acceleration, direction from the angular velocity information. If you have given the angular velocity variation with the time, you should be calculate all the information. And again, practice. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.